Hi, thanks for joining me today. My name is Brian Fentiman. I'm the Vice President and Chief Technical Officer for Blue Force UAV Consulting. Prior to starting Blue Force UAV Consulting with my partner David Dominy, I was with the Royal Canadian Mounted Police as a communications specialist. Also during my time with the Royal Canadian Mounted Police, I was a UAV specialist and developed training and technical solutions for that section. During that time, I was looking for a suitable law enforcement video live streaming solution, and I had troubles finding one. So I want to look today at what I've found and what I can recommend to others. So basically for law enforcement video live streaming, you need three things. You need a signal that is of high quality, high resolution. You also need a signal that has low latency, so you get real-time information coming back, not delayed by extended periods of time. And you also need encryption. And that is one of the big differences between standard public safety live streaming or broadcast live streaming and law enforcement live streaming. Quite often, you will require that extra layer of security. So in the form of encryption and in the form of higher security for the traffic passing through other companies' networks, things like that. So let's take a little closer look at each of those. So the first one being the resolution. So to get a high resolution signal through, you need a couple things. One is you need several transmission paths. A single Wi-Fi connection or a single cellular connection does not allow sufficient bandwidth to get a high definition signal through in most cases, unless you're in an urban center with very good cellular communications. So in order to make sure that your signal does get through during varying times of congestion, or if a carrier has a problem and you need another carrier to get your signal through, the suggested solution is what's called a bonded solution. In a bonded solution, you have multiple cellular connections simultaneously being used. The video signal is encoded, it's sent out through separate cellular connections, and at the other end it's recombined back into your video signal. So typically we would have a cellular modem that looks something like this that would be used to attach to your encoding device. So with a bonded solution, you would have 3, 4, maybe 6 of these cellular connections all connected to one encoder. So bonding, very important to get high throughput. The other thing you want is you want compression. You want high compression so that you can get the maximum resolution through that cellular system at a minimum data throughput. So you may have heard of H.265 and H.264 video. H.264 is an older technology that has less compression than H.265. H.265 is known as HEVC, High Efficiency Video Codec. That allows twice the information to be passed with the same amount of signal or the data throughput. So by moving from H.264 to H.265, you can get a higher resolution signal through that same size of pipe for the data to flow through. This is very important when you're dealing in rural areas or you're dealing with satellite signals even that you have to push high quality video through. So the next issue is latency. It doesn't do you much good to have a 30-second delay when you have an important call to make from a command center to the field, judging on what they can see in a video. So we're looking for delays of less than 3 seconds, and in most cases, we should be able to get it down to less than 1 second with the proper equipment. And finally, we talk about security, which includes encryption. In this category, we want to make sure that we can send video at the highest security level from the encoder directly to your command center with no middleman, thus allowing a secure path from A to B. And we want that signal to be encrypted. The standard federal encryption standard is AES-256. So with AES-256, we have a fully encrypted signal that cannot be monitored by anyone, and we're sending it point to point. So while looking for all of those qualities, this is what I came across. The Soliton Zao-S. So the Soliton Zao-S has all of these things. It bonds up to 4 cellular connections. It's compact. It has low latency. It uses H.265. It uses Raskau technology in order to make sure that your video gets through as clearly as possible without missing frames and jitter, things like that. And it's also AES-256 encrypted. It also comes with a software package that you can load on any computer at your command center, and it can then send directly, not through any kind of cloud system or other third-party company. You can go direct from this unit to your command center, point to point, fully encrypted. So the Zao-S is also a very simple unit to use. It's got a simple one-press power on, just a long press, and the unit starts up. There's an internal battery that lasts approximately an hour, and then there's also an external battery you can add to get about 2.5 hours of extra runtime. This unit can be mounted in a belt mount, or you can also mount it in this special carrier that comes with it. The unit bolts inside here with a simple screw similar to a thread for a tripod. And then this unit can also be placed into a backpack holder like this that allows you to mount this unit on and the Zao-S inside that. That way, when you couple these modems to it, they can tuck inside a cover like this and through the holes in the bottom. And so all the modems are kept contained in here. Your extra battery is in here. And then the unit can be closed up and worn over the shoulder in a compact package. Besides using a standard cellular modem, the Zao can also connect to an Ethernet connection just by using a different cable into the ports. You can see there's 3 USB ports here and a 4th USB port here that can also be used for a cellular bonded connection. There are 2 video inputs. You can choose between SDI or HDMI. Very simple. Put your video in and start the unit, and it starts streaming automatically. If you use a Wi-Fi hotspot device such as this, you can also connect that device to the Zao-S and use that. You can also hook up a USB cable to your cell phone and tether your cell phone's cellular data account to the Zao-S. Many different possibilities, very flexible, very simple, secure. I've been working with this unit for the past 2 weeks, doing some demonstrations with it. Very happy with it, very reliable, very easy to use in the field. Simple button presses to start and stop. Controls can be affected remotely through the software that's at the command center. So if the operator in the field is not able to start or stop the video stream or do other checks, that can be done from the remote end. So in part 2 of this video, I'll actually set it up with the drone controller here, and I'll live stream some imagery from the drone to a laptop, and you can get an idea on the latency and the simplicity of the unit. Thanks very much for watching, and we'll see you in part 2.